All right, so for this video, we're now moving on to section 6.4. And this video, what our objective that we want to be able to learn in this video is we want to know how to choose the best method for solving a system of linear equations. All right, we'll talk about this in class as to when certain methods are better or more efficient for you to use. We'll also have a slide that we'll cover on this video as well. But what I want to make sure that you understand in this is that you can solve systems of linear equations by any of the methods that we learn through graphing, through substitution, or through elimination. Any one of those methods works when you're trying to solve. And the best method, well, it depends on the type of question you have, and it also depends on how the equations are given to you. And then sometimes when you're solving through graphing, you might not be able to give the exact answer. So if you can't approximate answers, then graphing might not work. So it depends on the type of question, how it's provided to you, and what type of solutions you are trying to show. And you can use any one of these three at any given time. All right, so now let's go through when it is the best time to use these three. So the first one, graphing, if you want to have a visual display of the equations, or that the exact answer might not necessarily be what you are needing. Maybe you're just trying to look to see, will it be infinitely many? Will it be no solution, one solution? Or you just need to estimate a solution, then graphing might be the best one to use. Personally, graphing is the one that I use least. It's the one that takes the most time. And sometimes when you're graphing, if your y-intercept's pretty large, then your graphs might be fairly big and could be a little bit of a pain to graph. The other methods, though, substitution or elimination, either one of these you can use given on the certain problems. We'll talk about this more in class as to when you should use each one. So for here, when you use substitution is if you already have one of your variables solved for. So what I mean by that is if you already have y is equal to 4x plus 1. It's already set equal to y. So since it's already set equal to y, we can go ahead and substitute 4x plus 1 in. Or if it's easy to solve for one of your variables, so let's say this same equation that we just had, y is equal to 4x plus 1, if it was 4x or negative 4x plus y is equal to 1, since this y has a leading coefficient or a coefficient of 1, it's easy and quick to solve for that y by just adding over the 4x. So if it's one of these two cases, then substitution might be the easiest method to use. When you want to use elimination is when one of your variables are the same or the opposites, so that way it's easy for us to go ahead and eliminate that variable, or when it's not convenient to graph or substitute. So some examples might be 3x plus 2y is equal to 5. Well, if we tried to solve for one of our variables, x or y, it might be a little messy of a problem because 2 and 3 don't divide evenly into 5, nor do they divide evenly into themselves. So it could be a little bit of a pain to solve for one of those. So that might be a time where elimination is the best method. And we'll go through this more detailed in class. All right, so now systems of linear equations is actually something that you may use later on in your profession depending on what you do. But systems of equations are useful for modeling problems involving mixtures, rates, or break-even points, and that's something that we're going to do next. All right, but the break-even point for a business is the point at which the income equals the expense. So it's the point at which the amount of money it costs for you to make your objects is the same as the amount of money that you're making off of those objects. So that tells a business how much they need to sell of a certain product in order for them not to lose money. And then anything that they sell beyond that point is money that they will then be making because the income is then going to be higher than the expenses. So they will be making money at that point if they are able to sell those certain amount of items. All right, so now let's go ahead and do a problem using the break-even points. So here it says finding a break-even point. So we know we're going to find the break-even point. So a fashion designer makes and sells hats. The material for each hat costs $5.50, and they sell each hat for $12.50. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? So their costs are the $5.50 that it costs to make each hat, plus the $1,400 that they have to spend on advertising. That's still money that their company is spending. So it's still an expense that they have. And then the only thing that they have making any money is on each hat that they sell, it's $12.50. So we need to generate two equations, one for the cost and one for the revenue or the income. All right, so in this case, our cost would then be the amount of cost per hat. So it would be Y is equal to 5.5x, because that's how much it costs to make each hat, plus the $1,400 that it costs for the advertising. Right, and then the income that they have, Y is then equal to 12.5x. So for every hat that they have, they'll make $12.50. So this, we have a system of equations. So it's already set up for us to use substitution since both of these are equal to Y. So that means I can substitute this 12.5x in for my other Y. So I get 12.5x is equal to 5.5x plus 1,400. I'll then subtract 5.5x from each side. So it's 7x is then equal to 1,400. So now we would divide each side by 7, and x is then equal to 200. So that means that they would have to sell 200 hats in order for them to break even. So in order for them to not lose any money. All right, so that's an example of how we would use a system of equations to solve a problem in the business world. So now we're going to go over one more problem, but when we're going over problems in real world situations, you may need to consider constraints described in a problem in order to write equations. And then once you solve an equation, you also need to consider the answer, the viability of your answer, of your solution, meaning does it make sense? So after you get these solutions, you always want to check, does this actually make sense for the problem that we have? So for an example, if you get an answer when we're talking about time, well, you can't use negative hours because we can't travel backwards in time. So if we're using time and we get that our solution is negative, it doesn't make sense. So although it works algebraically, it doesn't work for the problem that we actually have. All right, so now let's do one more example and then we're done with this video. All right, so now for this one, the local zoo was filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. So that's one of the water tanks. And the other water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? Explain. All right, so that means we need to come up with 2 equations. We're going to come up with one for the yellow information provided, that one water tank is 50 gallons of water plus 10 gallons per hour. And then we're going to come up with the second equation for the green one. So the yellow water tank, Y is equal to 50 gallons it hasn't already, plus 10 gallons for every hour, plus 10 gallons per hour that's filling into the tank. The second equation has the equation that the total water that we have is Y is equal to 29 gallons of water, plus it's filling up at a rate of 3 gallons per hour, so 3 gallons for every hour that we are pumping the water in. We have a system of equations. Once again, it's set up for us to easily use substitution since they're both set equal to a variable. So we can just substitute this 29 plus 3x in for our y. So then we'll have 29 plus 3x is equal to 50 plus 10x. We will then subtract over 10x and subtract over 29. So then we have negative 7x is equal to 21. Divide each side by negative 7. X is then equal to negative 3. So let's just go ahead and plug it in to solve for a y. So y is then equal to 50 plus 10 times negative 3. So y is then equal to 50 minus 30. So y is then equal to 20. So our solution is negative 320 algebraically. But remember, we have to ask ourselves, does this make sense? X represented the amount of time that it took for us to make for the amount of hours that we're filling in these tanks for the water to be equal. Well, this came out to be negative 3. So that means in negative 3 hours the tanks were equal, which is impossible. We can't travel back in time. So this answer, although it does have a solution, the 2 tanks will not be the same because we can't travel back in time. All right, the tanks aren't going to stop filling and wait for the other one to catch up. So the two tanks will never be the same. All right, that is it for this video. And that's it for this video.